Chapter 3, we continue with Chapter 3, 3.2, Compounding Interest. The basic idea is that after the first integer period, the amount of interest is added to the principal amount, and then the interest is computed on this higher principal. So this is the main difference between the simple interest and the compounded interest. This is one example that you can see the growth of $1 compounded monthly at 6% interest in a 15-year period. That means the $1 is going to be around $2.45, as you can see from the graph. This is going to be the general formula. Again, A is the future value, P is the principal, R is the rate, T is the time. The main difference is the M, the number of compounding periods in a year. So if it's semi-annually, M is going to be equal to 2. If it is monthly, M is going to be equal to 12. If it's weekly, M is going to be equal to 52. And if it's quarterly, M is going to be equal to 4. Example number 1. Find the amount to which 1500 will grow if compounded quarterly at 6.75% interest. So we use the formula, and the future value will be $2,929.50. However, from now on we will use the graphing calculator. So let's go to see the steps. First of all, you have to go to Applications, APPS, and Finance, number 1. Click Enter. TVM Solver. And then, as you can see, you have the N. N is the number of years. In this case, this is going to be equal to 10. I will be 6.75%. The main difference between this example and before is that before the rate it was a decimal, but now we have to enter it as a percent, 6.75. Present value, this is the 1500. Right now we don't have any payment. If you don't have any payment, payment will be 0, and then the payments per year you keep it as 1. So if you don't have any payment, payment will be 0, P slash Y will be 1. And then C slash Y, compounding periods per year, will be equal to 4. Why 4? Because it says quarterly. So then you go to the future value, alpha, the green button, enter. And as you can see, the result is exactly the same, $2,929.50. Just to let you know, the graphing calculator gives you the future value as a negative number, but you don't have to worry about it. If you have present value and future value, one is negative, one is positive. But for the problems, use it as a positive number. And this is by using the graphing calculator. Let's go to see the second example. Exactly the same principle, exactly the same amount of years. However, instead of quarterly, it is daily. I give you the formula. Let's go to see what is the main difference by using the calculator. Let's go to C slash Y, it's daily, so it will be 365. Everything else stays the same. So we go to the future value, alpha, enter, and this is the answer, $2,945.87. Next one, the effect of increasing the number of periods. If the number of compounding periods per year is increased, the future amount of money will increase slightly, and we saw that on the previous example. Inflation rate, let's go to see this problem. In this case, the value of the house is 68,000 in 1987 and 104 in 2004. Assuming a constant rate of inflation, what is the inflation rate? So for this problem, we have to go first of all to calculate N, because N is 17. Why 17? From 2004 and we have to subtract 1987. The interest rate is the unknown. Present value is 68,000. Payment, we don't have any payment. Future value is 104,000. But don't forget, we have to use a negative number. And actually we have to use the negative with a parenthesis. This is the correct one. Negative 104. Don't use the blue key on the right, which is the minus. P slash Y is 1 and C slash Y will be 1 because the inflation rate is once per year. So now we go up to the rate, alpha, enter, and this is the answer, 2.53%. I give you the steps in the solution. I have to add of course the negative, but except that everything else is correct. So you solve for I and I will be 2.53%. Now, same problem. If the inflation rate stays the same for the next 10 years, what will be the value of the house in 2014? So, in this case, we go back. So we look now after 10 years. So N is 10. We keep the same inflation rate. The present value now is 104,000. So you look for the future value, alpha, enter. So the value of the house will be 133,529 and 47. Now, as you can see, it's slightly different compared to what I have by using the formula. The reason is that the interest has more decimals. I use 2 decimals, but if you use the exact number of decimals, it's going to be the answer that I have in the slides. Next example, and we follow the same steps. How long will it take for 5,000 to grow to 15,000 if the money is invested at 8.5 compounded quarterly? So we know the present value. The present value is 5,000. The future value is 15,000. Then the interest rate is 8.5. Compounding periods is 4. Why? Because we have it's compounded quarterly. So the N is the unknown. You can use the graphing calculator and then your answer is going to be 13.062 years. Now, continuous compounding interest. Previously we indicated an increasing the number of compounding periods while keeping the interest rate, principal and time constant resulted in a somewhat higher compounding amount. What's going to happen now if the interest was compounded daily or even every second? So if we have continuous compounding, this is going to be the formula. A is equal to P times E raised on the power of R times T. However, we can make one single transformation in the graphing calculator and we don't have to worry about the formula. Let me show you how. In this case, we want to see what is going to be the amount after 10 years if 1500 is invested at a rate of 6.75% compounded continuously. And this is the answer, $2,946.05 by using the formula. Now, we can use the graphing calculator, and the main difference is going to be for continuous compounding. We're going to use a very large number, a very big number, 1 million for example. So let's see this example. N is 10, then the rate is 6.75, present value is 1500, future value is the unknown. We have to go to P slash Y. P slash Y will be 1, and C slash Y, let's use 1 million. It doesn't matter if you use a million or 10 million. So let's go up to the future value, alpha, enter, and as you see, the answer is exactly the same. If we use the formula or if we use C slash Y, 1 million, $2,946.05. Next, we will talk about APY or the effective rate. the simple interest rate that will produce the same amount in 1 year is known as the APY, or effective rate. So if we know the nominal rate, we can go to use the graphing calculator. We have to go to finance, we have to go to C, and we have to go to effective rate. We have to enter the interest and then the number of compounding periods. And this is how we calculate the effective rate if we know the nominal rate. Let's go to see this example. What is the effective rate of interest for money that is invested at 6% compounded monthly? So let's go to graphing calculator. We have to quit from where we are, second mode to quit, applications, finance, click enter. Now you don't go to TVM solver, you scroll down to letter C, effective rate, and then 6%, comma is next to x square, 12. Why 12? Because it's compounded monthly. So the effective rate will be 6.17%, or the exact one I use here, 3 decimals, 6.168. Now, there's a possibility to know the effective rate and look for the nominal rate. Of course, the nominal rate will be lower than the effective rate. So if you know the nominal rate, you go to letter C for the effective rate. If you know the effective rate, then the APY, then to calculate the APR, you go to nominal. So for this problem, if the APY is 5.9%, what is the annual nominal rate? And this is monthly again. So let's go to see the graphing calculator. Again, second mode to quit and clear everything. Then we go to applications, we go to finance, and now we go to letter B, nominal rate. Click enter. Then 5.9, comma 12, because it's monthly. Close the parenthesis and then click enter. And of course this is going to be less than 5.9. It will be 5.75. 3 decimals, it's 5.746. As a result, to use the graphing calculator, we go to applications, finance, then you go to TVM solver, number 1, and then as soon as we don't have a payment will be 0, P/Y will be 1, and then we have the N, the I, the present value, the future value, and the C/Y, compounding periods per year. So as soon as we know 4 out of 5, we are able to calculate the 5th quantity. And then we have to go to use the nominal rate and the effective rate. So we go to letter B, nominal interest, comma, compounding number of periods, and C, effective rate, interest, comma, compounding number of periods.